A very good morning to all of you. It gives me an immense pleasure to extend you to a warm welcome on the behalf of MGB's Arts, Commerce and Science College, Malegaon City. Today we came here together over here for the occasion of the Earth Day. I would like to call our Vice Principal, Dr. Arif Anjum sir, for giving the welcome note of our today's program. Dr. Arif Anjum.
Thank you, Abdullah sir. First of all, I would like to welcome all the participants, all the viewers of today's webinar that is on Earth Day. So, and I also, on behalf of principal, college, and myself, and all teaching and non-teaching staff members, first of all, I would like to welcome our keynote speaker, that is Dr. Pramodkumar sir from HPT RYK College, Nasik. Sir, we welcome to today's webinar, and I hope that today's webinar will be much more helpful for the students and for all the participants. So once again, I thanks to Hire sir for accepting our invitation for today's webinar, and I hope today's program will be much more successful. And I also express best wishes for Department of Geography for conducting webinar on Earth Day. Thank you, Abdullah sir.
Thank you very much, sir. Today we came together on the occasion of the Earth Day. As you all know, the is Earth Day is one of the most widely celebrated environmental event across the globe. Earth Day is celebrated to increase the awareness and the appreciation of the Earth's natural environment. Originally, it was celebrated at the spring equinox around 21st March, but now the United Nations has designated 22nd April as the International Mother's Day, Earth Day. Earth Day is celebrated about the appreciating the uniqueness of the Earth planet, its incredible biodiversity. Earth Day is dedicated to increasing the awareness about the Earth. Today, more than 1 billion people now participate. Than 1 billion people now participate on the Earth Day activities each year, making it the largest week observance of the Earth Day. So this will be the brief of the objectives of today's webinar to make aware people about the Earth and the environment, how to protect the Earth from the harmful threats. So for this, I will give the introduction. It's time to introduce to keynote speaker of today's program. Here we are fortunate, really we are lucky that we have among us one of the great personalities of Maharashtra, an eminent writer, an eminent thinker, eminent scholar and speaker, Honorable Dr. Pramodkumar sir. He has vast experience in the field of education. He has a teaching experience of the 25 years. In the last 25 years, he has been inspiring thousands of students. He has published around 21 research articles and several national and international conferences within the country and abroad as well. He is one of the great geomorphologists in the state of Maharashtra. Sir, we are very grateful to you, sir. In spite of your busy schedule, you could manage some time for us and honor our request. Sir, we are really appreciate your efforts, and your efforts are praiseworthy in your field. Sir, I would like to welcome you on the behalf of my colleagues, my students, and all those who are present over here and those who are not present here somehow. Sir, I would like to request you to enlighten us with this beautiful couplet. खूबसूरत से एक पल का किस्सा बन जाता है, जाने कब कौन जिंदगी का हिस्सा बन जाता है. कुछ खास लोग मिलते हैं जिंदगी में, जिनसे कभी ना बिछड़ने वाला रिश्ता बन जाता है. I would like to call Dr. Pramodkumar sir to enlighten us. Sir, over to you, sir.
Yes, sir. I'm just sharing my presentation. Please hold on. And you'll have to tell me whether it is being properly shared or not. And also tell me, could you see, sir? Abdullah, sir, could you see?
Yes, sir.
The slide?
Yes.
Hmm?
Yes.
Could you also read on the slide?
Yes, sir.
Yeah. I'm just changing to the next. Is it being changed? Is it being changed?
Yes, sir. It takes
Could
some
you see
time.
the animation, please?
Yes, yes.
Okay. Thank you very much.
Okay, sir.
All right. So I'm thankful to Professor Abdullah for giving nice introduction of mine. I'm also thankful to Vice Principal Anjum sir, Arif Anjum sir, who had interacted with me a couple of minutes ago. I'm also thankful to the principal of the college for inviting me over here for the lecture on the occasion of Earth Day. And I also welcome all the teacher participants who are present and who will be listening to my presentation later on. And I also welcome all the students, participants who will be attending the lecture. Okay? I'll go approximately for about 1 hour. And if there are one or two questions, if at all they are there, then we can have some discussion and then I'll end with. Okay. Now, just now, Professor Abdullah has mentioned why we celebrate the Earth Day. And by keeping that only in mind, I would like to tell you in what way the Earth system works. So the title of my today's presentation is How the Earth System Works. The idea is not a new one because we geographers as well as the geomorphologists know about several basic theories and several basic things in geography and geomorphology, in geology, and overall in earth science. And I'm going to tell you about one of the basic theories, that is plate tectonics, which was published, which came to the world knowledge in 1950s and 1960s. On the basis of the work carried out by one of the noted geologists of the Prentice Hall University of USA. His name is Harry Hammond Hayes. Basically, he was a geologist, but during the Second World War, he was called to participate in the World War, and he was given the responsibility of fighting against their enemies for the submarine ships. And he had explored ocean floor at that time, and later on he has used that knowledge for putting one of the scientific breakthroughs in the earth sciences, that is the plate tectonics. Okay, but though we are talking about the plate tectonics, that has opened the knowledge. It is as there is the importance to the theory, like the Darwin's theory of evolution in biology, there is so much importance to the plate tectonics theory in the earth science. And that tells us in what way the earth system works, and that have changed all of our understanding in what way the earth system works. So my today's presentation is on how the earth system works. My next slide is a beautiful animation that can tell us for last millions of years how the continents and oceans of the earth have changed their position. So my next slide is that, and let's look at it very carefully. This is in the Cambrian period, about 540 million years ago. The period is changing, and look at the way how the continent, this is Ordovician, 475 million years ago. This is Silurian, about 430 million years ago. This is Devonian, about 400 million years ago. This is the next period, Mississippian, 350 million years ago. The next one is Pennsylvanian, 300 million years ago. Permian, about 275 million years ago. Triassic, 240 million years ago. Jurassic, 200 million years ago approximately. Cretaceous, 130 million years ago. Then Eocene, which come. There is Pleistocene, 50 million years ago. Eocene, 50 million years ago. Miocene, 90 million years ago, 19. And this is the present day situation. Okay. So it is really a very beautiful manifestation, animation in what way the Earth system has worked since Cambrian, that is about 540 million years ago. I mean, 1 million means on 1, you have to put 6 zeros, that is 1 million. So on 540, if you put 6 zeros, that is the 540 million years ago time, which is the Cambrian period. Okay? And since then, we could see the animation in what way the continents have moved and changed their position, and what is the present day situation of the continents and the oceans. Now, Mr. Abdullah, the slide had changed?
Yes, sir.
Okay. So I told you in what way the Earth system works, and that is basically, I would like to tell you about the theory of plate tectonics. Now, in what way the plate tectonics theory has developed over a period of time, perhaps, or not perhaps, but certainly many geographers and all the geologists and earth scientists know that around 100 years back, Alfred Wegener had put forward a theory. The title of his theory was The Distribution of Continents and Oceans, and it is more commonly known as the theory, it is more commonly known as the continental drift theory. And that is one of the basic ideas of the development of the theory of plate tectonics. But in what way it has developed, let's try to think about. Now, for any layman, forget about geographer, geologist, and earth scientist. For a common man, a theory of plate tectonics is a very simple one and straightforward explanation of how the Earth system works, how the Earth works. But why this theory wasn't discovered earlier? This is one of the basic questions I'd like to put in front of you, and I'd like to answer in my today's lecture. Why the theory of plate tectonics was not discovered earlier? Why was it discovered only about 60 to 70 years ago? That is my first question. The second one, I'll be telling you later. But although the continental drift theory, about which I have mentioned just now, was supported by convincing evidences, but the data upon which was originally based came only from the continents. Wegener had given the supporting evidences to his theory on the basis of data that was available only from the continental land masses, because there was difficulty prior to 1950s and 1960s. There was no effective mechanism to understand the ocean floor. The idea of ocean floor, in what way it looks, how it is, what kind of rocks it is made up of, and what are the relief features on the ocean floor. That knowledge came into existence, that information came into existence only after 1950s. And as I told you, in 1950s and 60s, a burst of new data and new ideas illustrated research efforts, scientific research efforts in two areas of the earth science. Number one is the topography and geology of the ocean floor. And as there are ups and downs on the continents, like there are ups and downs even on the ocean floor, that is known as topography. And geology means what kind of rocks are present on the ocean floor. Scientists had no idea about the topography and geology of the ocean floor before 1950s. And another most important scientific is the paleomagnetism. Now, what is the paleomagnetism? Paleo means ancient, very old, and magnetism means the magnetic field. How the magnetic field was operated in the ancient time, in the old time, that is called as paleomagnetism. So this is the second area. On the basis of that, scientists could learn that in what way the earth system is operating. Now, what about the topography and geology of the ocean floor? It is really very interesting. When scientists has explored with the help of radio sound equipments and with the help of marine submarine vessels, in 1950s and 60s, newly developed echo-sounding devices enabled marine geologists, earth scientists, and geophysicists to map topography of the ocean floor. And surprisingly, they found many more interesting things on the ocean floor. Number one, that the great mountain ranges, which are totally the total distance of all the mountain ranges on the Earth's surface is approximately 84,000 kilometers and about 1,500 kilometers wide. Such huge mountain ranges were present on the ocean floor. So as there are mountain ranges on the continents like Himalaya, Alps, Rockies, Andes, the biggest one, like that, there are mountain ranges even on the ocean floor, and their total length is 84,000 kilometers, and they are the longest mountain ranges present on the Earth's surface. So the longest mountain ranges present on the Earth's surface are not on the continents like Himalaya, but they are present on the ocean floor in the form of the mid-oceanic ridges. Say, for example, the mid-Atlantic ridge, and the total length is 84,000 kilometers, and it is about 1,500 kilometers wide. That is, say, approximately the distance between Nasik and New Delhi. That much wide is the width of the mountain ranges. Another interesting thing the scientists have found that these mountain ranges are not the mountain ranges which are present on the continents, because the mountain ranges on the continents have a crest, like the Mount Everest, Mount K2, or even we have the Sahyadri, we have, say, Kosubai, Dodabetta, Salil Muller. These are the crests which are present on the Western Ghat. There are crests which are present on the other mountain ranges of the world. But here, the mountain ranges that are present on the ocean floor do not have the crest, do not have the peak. Rather, the peak of the mountain ranges have a valley, which is about 1 to 3 kilometers deep. And that 1 to 3 kilometer deep valley appears like a rift valley. The valley, which is known as the rift valley. Rift means a gap between two crests. So that is known as a rift valley. So it appeared like a rift valley. And then they have concluded, the scientists have concluded that the longest mountain ranges present on the Earth's surface are not on the continents, but they are on the ocean floor on the planet Earth. And the longest valleys on the planet Earth are also on the ocean floor, which is beneath the surface of water, which is beneath the ocean water. And these were really a very interesting things scientists could found in 1950s and 1960s. Another important evidence is that scientists could note that the ocean floor or the ocean basins are relatively younger. They are made up of the younger type of rock. It means that the rocks which are present on the continents are older in age, and the rocks which are present on the ocean floor are much younger in age. So that is another evidence that the scientists could find. Okay, now this is the map, a very beautiful map, which can tell us between North America and South America and between Europe and Africa, there is a line. That line is nothing but the mountain range which is present in the middle of the Atlantic Ocean, which is known as Mid-Atlantic Ridge. Very interestingly, this is the Mid-Atlantic Ridge running from north to south, and the width of the Mid-Atlantic Ridge is about 1,500 kilometers. To your left, if you look at, there is one more ridge in the Pacific Ocean. So that is also the mountain range which is present in the Pacific Ocean. So with continents, these are some of the earth features which are present on the ocean floor. So the longest mountain ranges, longest valleys, and its width is about 1,500 kilometers deep. But if you really would like to understand in what way the Earth system works, then certainly we have to look at this very beautiful map of the world, which can attract our attention towards two prominent things which are present on the Earth's surface. One is the continent and other is the ocean floor. Everybody knows that there are 5 great continents present on the Earth's surface. If I name them, then in the center, North America, South America, Europe, Asia, Africa, Australia, and Antarctica. These are the 7 continents that everybody knows present on the Earth's surface. But there are 5 great oceans also present on the Earth's surface. To the north of 66.5 degrees north latitude, we have Arctic Ocean. To the south, 66.5 degrees south latitude, we have Antarctic Ocean. In addition to this, we have the largest one of the world, that is Pacific Ocean. Then we have north-south extent of the Atlantic Ocean. And fortunately, we have one ocean which has been named by our country, that is the Indian Ocean. That is also the ocean present on the Earth's surface. So we have 5 large continents which are present on the, 7 large continents and 5 great oceans. But really, if we would like to learn about in what way the Earth system works, again, my title of my today's presentation, we have to broaden our vision and we have to look at this map beyond the continents and oceans. We have to look at what is beyond the continents and oceans, and that I'd like to tell you in my next slide. But this is another seismic studies that has told us in what way ocean floor is mainly made up of basalt. Furthermore, ocean crust is not deformed into the folded mountain structures, as there are folded mountain structures like Himalaya is a folded mountain structure. Alps, Rockies, Andes are the folded mountain structures, and they have been developed because of the compressional forces that operate on the surface of the Earth. I had mentioned in the beginning of my presentation, in 1960s, Harry Hammond Hayes, a noted geologist from Prentice Hall University, proposed one theory. That theory is the sea floor spreading. He had told the world that the sea floor is spreading as we spread when we make chapati, as we spread when we make something, maybe the spreading of the cheese on the bread. So like that, the sea floor is spreading. On the basis of the new data that was generated from echo-sounding devices and suggested possible mechanism of the continental drift, which was the almost rejected theory up to 1950s and 1960s. And Hayes has postulated that the ocean floor is spreading apart by the convectional currents that are developing into the mantle and moving symmetrically away from the mid-oceanic ridges, say, for example, the mid-Atlantic ridge. And here, the convectional current, as the convectional current develops in the pot filled with water and the heat source is given from the bottom, like that, the convectional current develops within the Earth's interior into the astronosphere and mantle, about which I'll be telling you later. So the convectional current develop in the Earth's interior, and they are responsible, they are the driving forces for the seafloor spreading. This is what was told by H.S. Hess. Now, according to his theory, I'd like to show you only the diagram, but he says that entire ocean floor is regenerated in 200 to 300 million years, and Hess elaborated the theory of continental drift in the light of fresh knowledge and redefined in his theory that is known as the theory of seafloor spreading. Another thing is the paleomagnetism. This is a bit difficult concept to understand, but I can tell you very simply that the Earth has the magnetic field and everything is attracted towards the Earth north and south pole. So like that, some of the rocks and the lava also has the iron-rich material or iron, and when this lava is poured on the Earth's surface, it is poorly attracted towards the Earth's magnetic field because it is freely floating. But when the lava is cooled, like the water is converted into ice, when the lava is cooled, at that time, when the cooling takes place, the iron-rich material is attracted towards the Earth North Pole and South Pole, and then it becomes the fossil magnets. And at that time, when the rock was formed, what was the magnetic field of the Earth, and now what is the magnetic field of the Earth? After some movement of the rocks has taken place, scientists could learn about the paleomagnetism, which can be studied on the basis of the fossil magnets of the rock. So that is the scientific concept which I have tried to explain you on the basis of the magnetic field of the Earth. Now, this is about the planet Earth. Everybody knows the beautiful image of the Earth and how it looks from the space. This is the another Earth, how it looks from the space. But the Earth's interior is very important because whatever energy, whatever dynamics that comes from the Earth's interior, that comes from the internal, that comes from the Earth's interior, and therefore it is necessary for us to understand how the internal structure of the Earth looks like. Now, this is a very basic one. Everybody must have seen this diagram, and that can tell us about various layers of the Earth from the surface, like rocks, which is known as lithosphere, followed by the molten astronosphere, followed by mantle, followed by outer core, which is liquid, and inner core, which is in the center of the Earth. A very common diagram, very popular one. Every Earth scientist knows about it. So in this way, the Earth interior looks. And then if you see from the center of the Earth, we have solid inner core, liquid outer core, thick mantle, again, which is solid in nature, soft astronosphere, which is plastic in nature, like, say, capable of moving, like a toothpaste, for example, which is solid, semi-solid, that is astronosphere, rigid lithosphere, which is made up of rocks. And then we have hydrosphere, which is a sphere of water, and everything is surrounded by the gaseous atmosphere. But these outermost solid layers of the Earth are very important one. And look at their characteristics. The outermost solid layer is made up of two parts. One is the continent and other is the ocean floor. Ocean floor is also the part of the outermost solid layer. Continent is also the part of the outermost solid layer. Continents and ocean floors are different in characteristics. Continents are thicker, lighter. Ocean floors are thinner, denser. If the continents and ocean floor meet together, because the ocean floor is dense, the ocean floor goes down. And both of these are floating on the plastic asthenosphere, which is capable of moving from one place to other place. Another interesting thing I'd like to tell you about the continental crust had the folded mountain ranges like Alps, Himalayas, Rockies, and Andes, whereas ocean floor has the mid-oceanic ridges from where the magma comes out, the lava comes out and spreads on the surface of the earth at the ocean floor. Now, these are some of the important and interesting characteristics of the outermost solid layers of the earth. But here are the two questions which we would like to learn about. What exactly the theory of plate tectonics and in what way the earth system works? This is my first question that we are going to answer now. And second one is, what features does it produce? What kind of features are produced by the plate tectonics earth system on the surface of the earth? Now, if you look at this world physical map, very attractive one, I had shown you earlier also, and I also told you about the continents and oceans which are present on the Earth's surface. But about the tectonics, if we'd like to learn, then we have to take example of the football. Now, this is a football which is made up of several plates which are hexagons or the pentagons. Particularly, the white ones are the hexagons and the black ones are the pentagons. So, football is made up of several plates. Some of them are hexagons, some of them are pentagons. So, like that, the Earth's surface is also made up of plates. But there is certain difference between the plates of the Earth system, Earth, and the plates of the football. In case of the plates of the football, it is either made up of, at least in this diagram, it is either made up of hexagon or pentagon. Means their sizes and shapes are common. Whereas in case of the Earth's surface, the sizes and shapes of the plates on the Earth's surface are different, which I'm going to show it to you in my next slide. Now, this is really a very good diagram that can tell you about the plates which are present on the Earth's surface. And if you look at the top left diagram, then there are some plates, like in the north, we have North American plate. In the south, we have South American plate. In the east, we have Europe and Asian plate, that is the Eurasian plate. To the east, we have African plate. So in the top left diagram, you can see the four prominent plates of the world. And the right bottom diagram, you can see the Eurasian plate in continuation. You can see the Pacific plate to the east. You can see the Indo-Australian plate to the south. And you can also see the Antarctic plate to the further south. So as there are 7 continents in the world, there are 7 plates in the world. If we name them North America, South America, Eurasia, Africa, Pacific, Indo-Australian, and Antarctic. These are the 7 plates. And as there are plates on the football, like that, there are plates present on the surface of the Earth. So there are 7 major plates which are present on the surface of the Earth. Now, if I spread this in the form of the maps, because the Earth is spherical, 3-dimensional, that spherical surface can be transformed into 2-dimensional map. And if I make it into the 2-dimensional map, we can see these plates in different colors. And there are 7 plates and 5 great oceans we can see. Now, in this case, if we like to learn about the plates, the plate include some area of the continent and some area of the ocean floor. Take the example of South American plate. It includes South America continent, but it also includes the part of the Atlantic Ocean. Take the example of the African plate. It includes the Africa continent, but it also includes the part of the Atlantic Ocean. So all the plates include some area of the continent and some area of the ocean floor, except one, that is the Pacific plate. The Pacific plate does not include any major part of the continent except some of the islands like the Hawaiian Islands or the Philippine Islands. It also includes, it only includes the part of the ocean floor. But all other continents, all other plates include some area of the continents and some area of the ocean floor. So as I have mentioned, there are 7 plates in the world, large plates in the world, but there are several minor plates also about which I have not mentioned. And one of the best examples of the minor plates is our own example. That is the Indian plate is one minor plate. Adjacent to that is the Arabian plate. Then we have Nazca plate in the Pacific Ocean, Caucasus plate, John D. Fuca in the Pacific Ocean. And the Atlantic Ocean, we have Caribbean plate. In the South Atlantic Ocean, we have the Scotia plate. In the East Pacific Ocean, we have Filipino plate. So there are about 20 minor plates which have been identified so far in the world present on the Earth's surface, in addition to the 7 major plates. So these are the major tectonic plates which are present in the world. This is another map which tells you about the major tectonic plates. And this is the area of the tectonic plates. The largest one is the Pacific and the smallest one is the South American plate, which is made up of 43 million square kilometers area. Okay. Now, the theory of plate tectonics provides the master plan of the Earth's dynamics, that is, in what way the Earth system works. Basically, the term tectonics comes from the Greek word tektonikos, which means the building or construction. But here, what kind of building or construction? Buildings like the building or construction that we carry out for our houses and industrial establishment? No, building or construction on the Earth's surface. And tectonics is the study of formation, that is creation, and deformation, that is destruction of the Earth crust, that results into the large-scale features, very huge features, particularly the structural features which are present on the Earth's surface. The best examples of the structural features are Himalaya and mid-oceanic ridges which are present on the ocean floor. Now, the fundamental idea of the plate tectonics can be understood with the help of this convectional current. So, as the convectional current develops in water pot, in the similar manner, the convectional current develops means the hot magma comes up, cools down, again it sinks down. So, if you see in the bottom diagram, there is a current developed which is known as a convectional current, and similar type of convectional current also develops in the Earth's interior, particularly in the astrosphere. Now, this basic diagram can tell us very interestingly in what way the convectional current develops. You can imagine a situation. It is very commonly known idea and a basic knowledge that if you bring South America close to Africa, it fits very well. It means that these two continents were together. But how they got separated? They got separated because of the seafloor spreading, because of the idea which was put forward by Harry Hammond Hayes, that is the seafloor spreading. But how that seafloor spreads? If you see in the center of this diagram, we have the oceanic ridge, which is the mid-Atlantic ridge, and at that mid-Atlantic ridge, the magma constantly comes up on the surface of the Earth, and then when it comes on the surface of the Earth, it is known as lava. And when that magma cools, these two huge plates are little bit moved apart, And at these mid-oceanic ridges, the magma is continuously coming up for last millions of years, and even today it is coming up. And because of that, huge continents like the huge plates, African plate to the east and South American plate to the west, they are moving apart, and a new ocean floor is created, which is known as the new generated ocean floor. Say that is we can call, and as said by HSS, that the sea floor spreading. So in this manner, the tectonic system works. So if you look at the green color in the center of this diagram, that is the new ocean floor which is being generated, say about for last 200 to 300 million years. But in this manner, if the new ocean floor is created, then the size of the earth should increase and that should grow larger and larger. But that has not happened in the earth system. The size of the earth has remained constant for last million of years. Rather, since the origin of the earth, the size of the earth has remained constant. So as there is generation of the new lithosphere in one area of the world, in one part of the world, there has to be the destruction of the lithosphere in the other part of the world. And that takes place, if you look at the left-hand side of your diagram, there is South America, and then there is Pacific plate, particularly the Nazca plate. That Nazca plate is being subducted into the South American plate. So there, the deformation, there the destruction takes place. So at one place, the new lithosphere, the new land is generated. At the other place of the world, the old, or maybe the lithosphere is destroyed or the deformation takes place. And in this way, the earth system works. The tectonic system operates from the earth's internal heat, which is known as earth's dynamics. Here, I'd like to tell you about the margins of the plates, which are known as the plate boundaries. They are the most active areas on the surface of the earth because so many activities take place on the surface of the earth. So I'd like to tell you about the plate boundaries, which are the most active areas. Now here, the black lines are the plate boundaries in this map, and they are the most active areas on the surface of the earth. And very simply, the plate boundaries are of three types: divergent, convergent, and transform fault. I'd like to tell you about these plate boundaries in my next slide. That can tell you. Divergent means if you look at the red arrows on the top plate diagram, the arrows are going opposite, means they are diverting. So that is the divergent plate boundary. In the middle diagram, the arrows are towards each other. So they are converging. So that is the convergent plate boundary. And in the bottom diagram, it is the transform fault. The plates are neither diverging, not going away from each other, not coming close to one another, but they are slide passing each other. If you look at the arrows and their movement, it is slide passing each other. So that is the transform fault plate boundaries. So in this manner, there are three types of plate boundaries. Number one, divergent. Number two, convergent. And number three, transform fault plate boundaries. So these are the three types of plate boundaries which are present in the world. Very good diagrams to understand in what way the plate boundaries look. Another important thing about this, everything is beneath the ocean floor because you can see a blue plane, that is the ocean water. So this everything is beneath the ocean floor, and rarely it is on the continental margins also. It's not that it is not on the continental margins, but in these diagrams, at least it is beneath the ocean floor. This is the another diagram which can tell you about three types of plate boundaries. In the center, divergent, to the right, convergent, and again in the center, transform fault. Let's talk about one by one the divergent plate boundary because it diverts or it is known as construction margin because it constructs the new lithosphere. Let's talk about it. In what way it takes place? Imagine a situation in the top diagram. To your right, you have Africa continent, and to your left, you have South America continent. They were connected to one another in this manner. A gap has developed between them in the second diagram. The gap has widened between them in the third diagram. Then the part of the Earth's surface has subsided down, that is occupied by the ocean water, and the gap has widened much more between them. So in the bottom diagram on your right, if imagine there is Africa continent on the right and South America continent on the left, and in between Africa and South America continent, there is vast ocean, which is known as Atlantic Ocean. And in the center of the Atlantic Ocean, we have the mid-Atlantic ridge. The total such ridges on the surface of the Earth are 84,000 kilometers long, and it is about 1,500 kilometers wide. So in this way, the new lithosphere is generated. Here, I'd like to give you three different examples from the world. In the top left diagram, you have East African Rift Valley, means a gap is developing in the eastern part of Africa, and after a few million years, the eastern part of Africa will be cut off from the African mainland. In the second top right diagram, we have the Red Sea Rift. We have a narrow Red Sea. There was a news of the Red Sea and Suez Canal because one ship was stuck in the Suez Canal about 15 to 3 weeks ago. So that is a narrow Red Sea. And in the bottom diagram, more advanced stage of rifting, that is on your right, for example, it is Africa, on your left, South America, and then in between you have the Atlantic Ocean, and in the center of the Atlantic Ocean, you have mid-Atlantic ridge, which has a rift valley in the center, which is about 1 to 3 kilometers deep. So these are three different examples from the world of the rifting of the continents. Now this is the Red Sea, a very beautiful image can tell you about the Red Sea. Then the Red Sea goes there. There you can see the Nile River Delta. That green line is the Nile River, and there near the Nile River Delta to the east, you have the Suez Canal that reduces the distance between Mumbai and London for 7,000 kilometers, because earlier ships used to go through Cape of Good Hope from Mumbai to London, but that Suez Canal has decreased the distance between Mumbai and London. Okay, now this is the Red Sea Rift, you can see. Now the divergent plate boundary, about which are characterized by oceanic ridge. I have given you the example of the mid-Atlantic ridge. Rifting of the continents. Continents drift, a gap between the continents develop. Volcanic activity. The lava constantly comes up from the mid-oceanic ridge, and that is characterized by the generation of the new lithosphere. The next one is the convergent plate boundary. It is also known as destructive margin. Convergent means the plates come together. Destructive means one plate or the destruction, deformation of the plate takes place and the land is destroyed. The lithosphere is destroyed. Therefore, it is known as destructive margin. And here, there are three, again, very good examples of the convergent plate boundary. The top one is the ocean-ocean convergence. If you take the example of the Japanese island, to the east of Japanese island, you have ocean. To the west of Japanese island, you have ocean. But these two oceanic plates are meeting to one another, and the denser oceanic plate goes beneath. The second one is the continent-oceanic convergence. The best example is the South America colliding with the Nazca plate being denser. In the middle diagram, the Nazca plate goes down and South American plate overrides, and which forms the Alps mountain ranges. So in the center diagram, you can see some of the folded mountain ranges. That is the best example of the Alps mountain ranges. And the third one is our own example, that is the continent-continent collision, where the Indian plate collides with the Eurasian plate, and because of the collision, Indian plate being denser, that goes down beneath the Eurasian plate, and because of this collision, the mountain ranges such as Himalayan mountain ranges form. So that is our own example, that is the continent-continent collision. Okay? And look at the way in last 70 million years, how the Indian subcontinent has migrated to the north, collided with the Eurasia, and in what way, if you look at to your left-hand side diagram, beautiful Himalayan mountain ranges have been formed because of the collision of the continents, ranging from, say, right from Afghanistan, Pakistan, covering China, India, Nepal, and Myanmar. You can see the Himalayan mountain ranges. Okay, another very good manifestation of the Himalayan mountain ranges. Another three-dimensional panoramic view of the Himalayan mountain ranges. And these are the part of the Himalayan mountain ranges which are known as Suleiman Ranges of the Western Pakistan. And that has been created because the India collided with Asia or Eurasia, and Suleiman Ranges, which are the part of the Himalayan mountain ranges, have been formed, which are present in the western part of Pakistan. Now here we have the folded mountain ranges of one of the oldest mountain ranges of the world, Appalachian mountain ranges. These are Appalachian mountain ranges again. These are Appalachian 1. And here, ocean-ocean collision. These are the example of the Japanese island. You can see the ocean-ocean collision. And many volcanic eruption takes place in Japan. Mount Fuji is one of the best examples of the volcanic eruption in Japan. And here we have the world folded mountain ranges. In North America, we have Rockies. In South America, we have Andes. In Europe, we have Alps. In Asia, we have Himalaya. Okay, these are the Himalayan mountain ranges at Kulu Manali. And what are the major features produced at the convergent plate boundaries? Folded mountain belts. Best examples are Himalaya, Alps, Rockies, Andes. Deep sea trenches and island arcs. The best examples of the deep sea trenches are Mariana Trench, island arcs. Examples of are the, say, Aleutian Islands or Japanese islands or even the Hawaiian Islands. Volcanism. Volcanic eruption takes place. Say, for example, in Alps mountain ranges, there is volcanic eruption. And the next one is earthquakes. Because the plate collide, earthquakes are certainly going to happen. Okay. The next one is the transform fault plate boundary, which is known as conservative margin. It is neither destructive nor constructive. It is conservative because the continents, because the plates are neither destroyed nor created at the transform fault plate boundaries, because the movement is horizontal, and it is characterized by two processes: fracturing, cracks develop on the land, and earthquake takes place. That is, these are the two characteristics of the transform fault plate boundaries. Now here we have very excellent example of the transform fault plate boundary, that is the San Andreas Fault. And it's not that we do not have the transform faults in India. We do have several transform faults in India which we have been studying. But here is a very good and the best example of the world, that is the San Andreas Fault, where the North American plate moves to the southeast and the Pacific plate moves to the northwest, and that creates a San Andreas Fault. And because of the San Andreas Fault, there are many major earthquakes at San Francisco and Los Angeles of USA. That is the Californian coast of USA. Now, this is the another satellite image of the San Andreas Fault. You can see the difference along these lines, and that is nothing but because of the faults. And here are very good, here is the very good map of two types of the dots. One is green in color, other is red in color. The green dots indicate volcanic eruptions. The red dot indicate earthquake. And if you join these dots by line, certainly you can automatically demarcate the plate boundaries. What does it indicate? It indicates that 90% of the volcanic eruption on the surface of the earth and about 90% of the earthquakes on the surface of the earth occur along the plate boundaries. And that is why the answer of my question here, which was raised earlier, that is, the plate boundaries are the most active areas on the surface of the earth. Why there is importance to the plate boundaries? Because the plate boundaries are the most active areas on the surface of the earth, because 90% of the volcanic eruption take place along the plate boundaries and 90% of the earthquake occur along the plate boundaries, and that's why they are the most active areas on the surface of the earth. And if you join these red and green dots, automatically you can demarcate the plate boundaries, plate margins, which are the most active areas on the surface of the earth. And with this beautiful map, I would like to end my presentation. I'm thankful to all of you for patient hearing. But I'm thankful to the principal of the college. I'm thankful to Vice Principal Dr. Arif Anjum. I'm also thankful to my student and now Assistant Professor, Mr. Abdullah, and I'm thankful to all the teachers who have participated and who will be listening my presentation later on, and all my dear students who will be listening my presentation later on. So with this, I end with this beautiful monument of the world, Taj Mahal, which is made up of one of the rocks in geology, that is the marble, which was brought from Makran of Rajasthan, and really a wonderful creation on the surface of the earth by Shah Jahan, which was completed in 1653 in Agra. Okay? So thank you very much. Have a nice day.
Thank you very much, sir, for your helpful information about the Earth Day.
Yeah.
We are very grateful to you, sir, to give your time for this occasion of Earth Day. We are very grateful to you, sir, and thank you very much, sir.
Yeah.
Now I would like to call Professor Imran Ahmed to extend vote of thanks for today's program. Professor Imran Ahmed, over to you, sir.
Thank you, sir. Am I audible?
Yes, yes.
On behalf of Mahatma Gandhi Vidya Mandir, Arts, Commerce and Science College, Malegaon City, I, Professor Imran Ahmed, presents my sincere vote of thanks to our today's keynote speaker, Dr. Pramodkumar here, sir. Sir, it was very informative session in which you talked about Earth Day. Thanks a lot, sir, for sparing the time. You helped us to organize this webinar very well. We are very obliged and thankful to you from bottom of our hearts. Thank you, sir. Thank you for being with us. Thank you. Thank you very much. I'm also very much thankful to our beloved principal, S.C. Hale, sir, Vice Principal and Nodal Officer, Dr. Arif Anjum, sir, IQAC Coordinator, Hamdani Rizwana, ma'am, College CEO, Dr. Shakib Ahmed, sir, and Professor Abdullah, head of the department Geography, and the organizer of this webinar, and all the teaching and non-teaching staff who directly or indirectly being instrumental in organizing this webinar. And last but not the least, all the participants who attended and listened this webinar. Because of you all, this webinar is great success. Thank you very much. Over to you,
Yeah,
Abdullah sir.
thank you.
Thank you very much, Imran sir. At last, I would like to thank all of you who are present here, who have attended this webinar, and I'm very thankful. Lastly, to the keynote speaker of today's program, Dr. Pramodkumar here, sir. Thank you very much, sir, and thank you to all of you.
Okay, thank you. May I leave now?
Yes, sir.